value. That we will be doing it. You give the training to the network, you give the training to the model and then adjust it. That is called regularization, balancing your neural network from affected by overfitting and underfitting. So here the normalization is done before you could give the training itself. How much amount of training must be given to the neural network or deep neural network is decided or performed by batch normalization. Okay, please remember, regularization is you do something, later on you adjust your network by performing L1 or L2 in a dropout, bagging, early stopping. By all those methods we will be able to balance the neural networks. Whereas batch normalization or just normalization normalize the network before we could give the training itself. That is the main difference. So why the normalization is required? How do we achieve this? So you have a neural, whenever we speak about deep neural network or just neural network, it will be involving multiple hidden layers. There will be lot of hidden layers, only then we say that it is a deep neural. A process is done through various levels, various layers, then we say it is a deep neural network. Okay. So here in batch normalization or how to apply batch normalization, we take just a batch of the layer, not the complete layer. A part of the layer, a batch of the layer alone is taken, on which mean and standard deviation is computed, through which we perform scaling and shifting, so we could achieve normalization. Please try to understand. We take only a batch of the layer, only on batch we will be applying the normalization, and that will be scaled later or shifted later throughout the layers. That is how normalization is approached or applied on a neural network. Okay, so now you can take down the proper definition of it. Batch normalization is a technique which I have written already in it, if not right. Batch normalization is a technique used in deep learning to improve the training of neural networks, by normalizing the input of each layer. By normalizing the input of each layer. Vijay, can you please get up and read what you have written? Just read from your notebook. Get up and read. Stand. Huh? Yeah, read what you have written. Huh? Then what are you doing? Mukul. Yes, you can read. I told you to read what you have written now. Read. What is batch normalization? Huh? Look at me and answer. Why are you looking there? Vishwa, pass this. What are you doing here in the classroom? Inge pakra points about it. Batch normalization, accelerating deep networks, deep network training by reducing internal covariate shift. By reducing internal covariate shift. Okay. So here we will be performing something, scaling and shifting. Some internally we will be adjusting the nodes. If you just remember the dropout method of regularization, we used to enable and disable the nodes according to the requirement. Some nodes will be disabled and then we will be performing. If it goes well, we will proceed with that itself. And for some other training or some other testing, we will be enabling or disabling some other nodes. That is the process. Like internally we will be shifting some nodes or some variables, some parameters or some input. Okay. So here in the batch normalization, to avoid that only, we will be applying normalization on a batch. To perform or to achieve this normalization or regularize this, we take only a batch of the layer and then perform. So when we are taking a batch, a small portion of the layer, what are all the things we will be doing? So we perform or we do something called normalization. Normalization. So we don't even have some of the steps, some three main steps we will be applying on a neural network to achieve batch normalization. So what exactly the normalization? Given a mini batch of activation, we take a mini batch of the entire network or entire layer, given a mini batch of activations from a particular layer. You take one particular layer, in that you take a mini batch where you are having the elements as x1 to xn, x1 to xm or n, whatever it may be. So n is the batch size. First batch normalization calculates the mean and standard deviation. Mean and standard deviation. So first step we will be performing normalization on a batch. So here I have taken a batch of x1 to xn of a particular layer. I take only one layer, so we do it on layer by layer only. Okay, we don't do on the entire, both of you sit down. So we don't do it on the entire network at a time. We take only one layer, which also a small batch is considered. For that we will be calculating mean and standard deviation. How do you calculate mean? So we take one problem and then solve, and that time I will show you. So for time being, note down the formula. So we will be calculating the mean as very simple, add everything divided by the number of elements. That is only mean, but we use the different symbolic notation over here. That's it. Sum of I is equal to 1 to n. My batch size x I. Whatever the elements you have taken, sum of all divided by n. Divided by n. Okay. So that is how we calculate mean, and then standard deviation is calculated as each element minus the mean what you have already computed square. Sum of all that will be the standard deviation. So on a mini batch, we don't take the entire batch, we take a small mini batch of one layer. For that alone we calculate this is mean and this is standard deviation. Standard deviation. So this is the process is done on a particular mini batch. Next comes to the next step will be again the normalization only, but here we will be extending the process. So second step is also a normalization, which will be on a whole batch. Normalization. So the activations are then normalized using the mean and standard deviation. We are going to use the mean and standard deviation on the activation function, which will be performed by the computation as xi minus the mean divided by square root of standard deviation square plus epsilon. So we do use the activation function. We all know that our neuron is computed, or our neuron or perceptron is processed. You take the input, multiply with the weight. Okay. So then apply activation function on that. So whatever it may be, the activation function is considered. So on that we will be performing, like instead of activation function, we will be performing this. Okay. So first normalization on a small batch. So next using the calculated mean and standard deviation, we will be computing this. Third step is scaling and shifting. So here epsilon is a small constant. So normally we take some some numerical value. Epsilon instant, like epsilon is just a constant, like how we take bias. We will be taking bias as a constant value which will be added at the time of activation. Same way here we are adding epsilon, which is just a numerical constant only. So this is normally added to avoid the division by zero problem. So whenever you do any computation, especially the division is involved over there, we may by mistake give divide by 0. When it is divide by 0, you get an error. Correct? So you will not be able to say it is infinity. You get an error called divide by 0. Even in your C language or any other programming languages, you get such error. To avoid that only, we will be adding some constant over there so that it will not become 0. It will become some values over there. Okay? So here in the normalization process, we are computing x cap. What are we doing? Instead of x, xi cap is computed. So x1 is modified with some other value. x2 is modified with some other value. We have taken initially x1, x2, x3, etc. xn. Right? So those values are modified in such a way that xi cap, that is x1 cap, x2 cap, x3 cap, like that it will be updated. While doing so, we will be performing some division with the square root. So here we are adding one epsilon. It is just a constant with some numerical value. It is only for stabilization purpose. Okay, there should not be any divide by 0 error. So next step is scaling and shifting. Scaling and shifting. We perform the third step as scaling and shifting. So here the normalized activations which we had got it over here. The normalized activations are scaled and shifted. So it will be expanded or reduced depending upon the sign of the value what you are getting. Okay, so you may have to reduce your x value or you may have to increase the x value. Whatever the values you are getting in the normalization steps will be a shrink or expanded value which will be shifted across your network. So that is the step in here, scaling and shifting. Please make a note of it. The normalized activations are then scaled and shifted using learnable parameters. Scaled and shifted using learnable parameters. Learnable parameters which are updated, updated will write later. So the learnable parameters are represented by gamma and beta. So these learnable parameters, so this is used for scaling purpose and this is used for shifting purpose. Scaling and shifting, this will be used again. We will go back to our back propagation where the gradient descent will be computed and that will be used for the updation of the weight. Okay, so there we will be using this gamma and beta. So how do we perform or how do we apply this scaling and shifting? Again there is a computation. Yi is equal to gamma into xi, your normalized value, plus beta. So normally our yi will be, how it will be? Xi into wi, sum of xi wi, right? And then we will be applying activation function normally in any of the neural network or neural computation. But here, since we are normalizing it, we are performing some normalization on a small batch and then we are updating on the input variable xi or the batch elements and then we do perform scaling and shifting. Okay, so by doing so you are getting the output as yi is equal to gamma into xi cap, that is your new value what you have got after your normalization. plus eta. This is the formula. So there are three steps we are doing. Number one, normalization on a small batch, mini batch. Number two, normalization on the entire batch. Number three, scaling and shifting. Okay. So by doing so, all the three steps, we are able to normalize our network. Normalize our network. So this normalization technique is used to avoid giving overfitting or underfitting. That is before you could give the training itself. The other method, regularization, is after the training is done, you find out it is overfitting and you regularize it. Or you find out it is underfitting and then you regularize it. But here, before you could train your model itself, decide what to be given for the model. That is being done with the support of normalization technique. Fine. So can we solve one problem? And before to that, take down few benefits out of it. Benefits of this normalization will be reduced internal covariate shift. Benefits reduced. Mainly this is being introduced for internal covariate shift. Internal covariate shift. So after doing, we should not adjust the weight. We should not if it is required, we will be doing it every time. In the back propagation, what are all the things we are doing? So from the output, you are going back to the input, right? If you are having some 100 layers in between, 100 hidden layers are there, all the values will be updated. Not only that, if one output is impacted by more number of input on all the lines, you need to update your weight. Okay, so that is the internal covariate. So accordingly, we will be shifting. So to avoid that, we are doing at the beginning itself. So that is one of the benefits. Number two, regularization. 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 So this is also a kind of regularization only. So there, after the training, we are regularizing our network. But here, before we could do itself, we are able to find out these are the things must be done. Accordingly, we are regularizing our network. That way, that is beneficial thing. Third, stabilizes learning. Stabilizes learning. Stabilizes learning. So the learning of the network is also stabilized because you decide this is what must be given. So I need to know how many questions should be given for you to prepare in a single day. Once I know that, I will be able to give only that many questions. Otherwise, I may tell you to prepare 10 questions. Next day I am asking you to write a test. So that time you are saying that ma'am, the number of questions are too many, so we could not prepare, and on the whole the entire class has not attempted well the test. Then I came to know, then I am realizing that I have given overburden. So then I reduce it. At that point of time I say that it's okay. So you consider only 5 questions, you have a look at that and then immediately you write the test. Instead of doing so, before itself, if I know that are you having any other works, you are having work, you need to write observation, or you are having any other test, you are having any other events, by checking all that, if I am planning to give you less number of questions which you will be able to prepare very well and give the exam next year. Okay, that is what is happening in the normalization. Okay, so this again checking the informations from you. I cannot ask each one of you. Instead, I am collectively take 2 or 3 students and then asking you, tomorrow do you have any other test? Are you having lab? Do you need to write observation? Or you need to perform anything else? All those things I come to know. Based on that, I assign the task. As simple as that. Okay, side out, get up. Yeah, please summarize the steps what we went through on batch normalization. Yes, tell me what is the first step in batch normalization? You just heard, no need to read and all. If you had listened, really you can answer. What are all the things we did? Bhuvneshwaran, what is the first step in batch normalization? Get up. Tell me. What is the first step? Sorry? I am asking about what are the steps in batch normalization in which I want you to tell me the first step. What is the first step? What? Mean. You need to find out mean on what? On what? Can I get the answer from the previous bench? Next to Mukund. Next to Mukund. Yeah, K7. Get up, K7. Sairagam, you have the answer now. What is the first step? I hope you were discussing that only with Pavitran. You both were discussing the same. Then, what is there to discuss in the class? And the class is going on. So, I want Bhuvneshwaran, K7 and Sai Raghav to write the formula of all the 3 steps in the lunch break and give me. Okay, sit down. Yes. So, we are going to take one simple example and apply the batch normalization on the same. Okay. So, take down. Let's assume we have a mini batch of data. Let's assume we have a mini batch of data with the 3 samples, and 2 features. 3 samples and 2 features each. So the batch, what I am taking here is, batch will be so we have taken a mini batch, it's not a complete layer. In a layer, we have taken a mini batch only. Okay, so the mini batch is having 3 samples, each sample is having 2 features. Okay, so first sample, the features are 1 and 2, 3 and 4, and 5 and 6. All the 3 samples. So now we are going to apply batch normalization on this. Okay, so step 1. Karun, can you guide me? What is step 1? What we are supposed to do? No need to tell me the theoretical part and all. Step 1, what are the things we are doing? Simple single statement I want. If not, even Mukesh can help him. Mukesh, yes? What we are doing in step 1? Get up. Step 1, compute mean and standard deviation on a mini batch. Compute mean and standard deviation on mini batch. The mini batch, what is taken here is this. So on this, we are going to find mean and standard deviation. You have the formula with you. You can start solving it or wait for me to compute and copy. Mean is equal to 1 by 1. I am going to do the first step. 3 samples here and each having 2 features. So the first one will be 1 plus 3 plus 5 divided by 3. That is mean. Number of elements. Okay. So 1, 3 and 5 divided by 3. Similarly, the second one will be 2 plus 4 plus 6 divided by 3. So I am getting the mean as 3, 4. This is the mean. This is the mean. Okay. So your standard deviation will be standard deviation. Both of you can sit. Punishment I will tell you later. You should also write. Okay. Formula. I want both of you to write the formula and submit. Only then you are allowed for the next class. So what is the formula for standard deviation? N. Okay. So from the formula, what you have understood that you apply. What we are doing? Your element minus mean. So element is 1 and mean of this is 3. 1 minus 3 square plus sum of only no, that is sum of I is equal to 1 to n. So 1 minus 3 square. Second is 3 minus 3 square plus 5 minus 3 square. Okay. So all that divided by 3. Correct? For 1. So second one also in the same way. 2 minus 4 square plus 4 minus 4 square plus 6 minus 4 square divided by 3. Finally also you can divide the issue, right? So what are you getting for this? Find out the answer and tell me. Very simple calculation only. Find out and tell me what are you getting as variance. First step, normalization on a small batch. Yes. You will be getting value as 2 minus 2. 2 minus 4 will be minus 2 square will be 4 and this will be 0 and this will be again 4. You will be getting value as 8 by 3. Am I right? 8 by 3. Similarly, the second one, oh, we will put that also will be same. That also will be 8 by 3. Standard deviation formula is again we are doing square. Square it. Anyway, are we doing square of this value? Okay. So this 8 by 3 can be simplified and taken as 2 comma 2. 2 comma 2. This is our standard deviation. Are you able to follow this? Now we need to do square of this. Yes, no? Because we are getting this as only delta. Okay, so this needs to be squared. So this value is taken as 4 comma 4. After getting the value, you need to square it. Please remember, find out the standard deviation. To find that, we apply this formula, but then you need to square both the elements. So finally, you will be getting this value as square is equal to 4 comma 4. So we have done normalization on a mini batch alone. So now we need to do for the entire batch normalization on a whole batch. Please remember, step 1 is normalization on a mini batch. Step 2 is normalization on a batch, whole batch. So that will be the next step. So your normalized batch will be, again you have a formula, normalized batch, and to Rakesh, please read the formula for normalized batch. The next step is, how are we doing that? Xi minus mean. Mu is nothing but mean. So I will take only one element and then show you. So first element is 1 minus the mean of that sample is 3. Then square root of standard deviation of that is 4 plus epsilon. This I have done for only one element. Only one element. So what we are supposed to do? We need to find in this way of all the elements. We are not doing any sum or something like that. We are only finding out what is x cap. Xi cap. Am I right? Xi cap. So here I have done it for only x1. So this is x1 cap. x1 cap. Similarly, you need to do it for x2 cap, x3 cap, and other things. If you want to name it as x11, 12, 13, without name also you can just do it. Okay. So now can you apply and find out? Like a matrix system, you can take, if you are getting any confused, the same thing 1, 3, 5, how it is going to be changed as 1 minus 3 divided by square root, square root of 4 plus epsilon. Right? Similarly, 3 minus 3 divided by root of 4 plus epsilon. Am I going correctly? Yeah. Next will be 5 minus 3 divided by root of, suppose 4 only, no, 4 plus epsilon. Correct or not? Similarly, for the second feature 2. The second feature 2 minus, without name of this is what? It is 4. 2 minus 4 divided by root of 4 only is the standard deviation plus epsilon. Complete this. This is our x cap. Complete this. Are you able to follow this or not? Very simple calculation only. You only need to apply the formula on the data. Complete this. So it will be 4 minus 4 divided by root of 4 plus epsilon, and this will be 6 minus 4 divided by root of 4 plus epsilon. This is my x cap. x1, x2, x3, all the elements are changed now. So we have done step 1, normalization on a mini batch. Step 2, normalization on a batch. And step 3 is scaling and shifting. Scaling and shifting. So scale and shift the normalized value. Whatever the values we have got, using which we are going to perform scale and shift. Shall I wrap this? This part is clear. So here we need to know what is gamma and beta. Gamma and beta are going to be helpful in shifting the thing. So let's assume internal value for gamma and beta as internal value for gamma and beta as 1 and 0. 1 and 0, which means gamma we are going to take it as 1 and beta we are going to take it as 0. Normally we take zeros and ones only as a scaling and shifting values, because we don't go for big deviations and all. Very slight deviation, very slight scaling and shifting we will be doing it. So we are initially taking this as 1 and 0, using which we are going to do scale and shift. So how do we do that? Scale and shift your batch. Scale and shift the batch. Yeah, gamma is 1 and beta is 0. We are going to perform scaling and shifting. What is the formula given over there? Yes? yi is equal to, this is what we are finding out now. Yi is equal to, we will take only one element. Suppose y1. This is the case. Yeah, tell me. Yi is equal to, what is the formula? Gamma applied value over there. We have not computed it because we have not applied value for epsilon. Right? For all other values we are having. For epsilon we have not taken. Suppose you are taking epsilon as 0.01 or just 1. Let us assume epsilon is taken as 1. Epsilon is taken as 1, or we can even take some other value 3. I take numerical value is 3 to get some sensible values. We are going to do it manually. So I am taking some sensible values over there. This is my x1 value. So I have taken epsilon as 4. So what is the value I am getting over here? 1 minus 3 will be 2 divided by root of 4 plus 4. Okay, epsilon I am taking it as 4. So it will become 8. So 2 divided by root of 8, root 8 will be getting some values. 2 divided by whatever the value you are getting. So that will be here xi. Are you getting any value? Please tell me that. I have taken epsilon as 4. Epsilon is just a constant, numerical constant value to avoid divide by 0 error. Okay, I have just taken epsilon as 4. With that, the value what I am getting here is, you have the calculator with you, right? Why don't you calculate and tell me? 2 divided by root 8. Find out the value for root 8 and then perform division on this. 2 divided by the value what you have got it. Find out and apply that value over there. Plus, say I have taken epsilon as 4. Need not to be only 4 for epsilon. It can even be 1. But it should not be 0. To avoid having 0 only, we are going with adding this value. Take epsilon as some numerical value from 1. Okay, with that, compute this and apply on it. We will be getting some value. That is the final output value. We are performing scaling. Okay, and that is being done by this formula, this process. Complete this. For all that is to complete. Now, formula which one? This one. 0.7. Okay. After decimal point, just take only 2 digits. One way is that apply this formula and get it done, scaling and shifting. The other way is that you can use gamma for the first feature and beta for the second feature. Gamma for the first feature, beta for the second feature. So if you are taking in that way, the formula would be 1 by, what is the gamma value? Square root of your 4 plus epsilon. 4 plus epsilon. Gamma by your x cap. Gamma by whatever the value you are getting. Square root of all that. Okay? But this will not be so effective. This will give same value only. That is why this normally we don't take, we go with this method only. But the variation you must know. Gamma is used for the first feature, beta is used for the second feature. topics